Hello viewers, welcome to Physics with Sanmitra. I am Sanmitra Bhomik and today we are going to provide the solution of Newton's laws of motion level 1 problem sheet, that is of NEET and you can say this is NEET and JEE mains level. So I have already distributed the sheet and I am going to attach it in the link in the description also. So let's begin. Our first problem here, we have a string here, and this string is actually we have a spring here, and this spring is having two mass of block A and block B, that is of mass 3m and m, and between them they are connected by a string here. Now we have to this string is massless, that means this is massless, and the system is in equilibrium. This string is cut and the magnitude of acceleration of A and B after the string is cut. That means what they are telling is that this string that I am cutting, then what will happen? This will fall. Now what is the acceleration after being cut? What is the acceleration of A and B? Now let's do it. See, initially this was A was like this and B is like this, and they are connected by a string, and above that this is connected by a spring also. Now what I am doing here, at equilibrium, what is the case? Let me see. This is 3m, this is m, so that spring that is applied at equilibrium, this whole arrangement will be pulling down by 4 mg. It will be pulling down by 4 mg, and so this force will also be 4 mg. This force will be 4 mg. Now what I am doing here, now just see, this is 3m, this is m. Now this force I have already shown, that is 4 mg, because it is balancing the weight of 3m and m. Now I am cutting this, string. Now what will happen? Now this is simply under the influence of gravity, that is g. The second block acceleration will be g. And what will be the acceleration of this block of mass of 3m? See, this block is having a weight that is acting 3 mg downwards, and upward it's 4 mg. So what is the net force that will be upward? That net force, I can write F is 4 mg minus 3 mg. So the net force will be mg. So what will be acceleration? Net acceleration will be net force mg by mass is 3m, so that is g by 3. So net force will be my g by 3. So my option, so acceleration of A is g by 3, acceleration of B is g, so my option A is the correct answer. Moving on to the next problem. We have three blocks of mass A, B, A, B and C, which are having masses 4, 2 and 1 kg respectively, and a force F is applied here at block A. Calculate the contact force between A and B. That means here, in between I have to calculate the contact force. Let's see how to do this. See here, first of all, let me draw here this is block A. And block B and C I am drawing separately. We are doing the free body diagram, and block B and C I am considering it together because we are not asked to find the contact force between B and C, but since between A and B we are asked to find the contact force, so we are drawing it like this. Now I am applying a force of F. What is F? F is 14 Newton. So here there will be contact force between A and B, that is R. Let's say this is also R, equal and opposite. And what is the mass of A? Mass of A is 4 kg. Mass of B is 2 kg. Mass of C is 1 kg. Now let me write the force equation, and all of them are accelerating with an acceleration of A. Since they are moving together. Now what I can write here? 14 minus R is equal to, in this x direction, 14 minus R, that will be equal to 4 into A. And here this 2 plus 1 3 kg, R is equal to 3 into A. If I add them, I will get 14 is equal to 7a, or a is equal to 2 meter per second square. Now I am getting a is equal to 2 meter per second square, so r will be 3 into 2, that is 6 meter per second square. So I got my r, the value of r, reaction force, that is the contact force between A and B. So my correct answer is 6 Newton. Okay, now move on to the next problem. Mass m1 m2, see, we have an arrangement like this. We have a block like this, and this mass m1 is hanging, this m2 and m3 are on the rough surface mu, and this is a rough table, and we have to find the acceleration of mass m1, and given that it is slipping, since we are asked to find the acceleration, we have to assume that this is slipping, and this will so this friction is not enough to stop this m1 from falling. Okay, and also we have been given that m1 is equal to m2 is equal to m3, m1 is equal to m2 is equal to m3. So what we can do, we can club these two blocks as a single block of mass 2m, and this is mass m. Now our problem becomes like this. This is mass m is hanging here, and this is 2m, block of mass 2m. See, I will draw the free body diagram of both. See, here tension T is acting here upwards for mass m, and here mg is acting downwards. Mg is acting downwards. Here what is happening? Here tension T is acting this side. Since this is slipping, friction F will act this side. Now what is F? See, this is normal reaction N, and down it will act, that is 2 mg. So N will be 2 mg. So I can write here, let's say all are moving with acceleration a. This is moving with acceleration a, and since they are connected with the same string, so it will also move with an acceleration a according to the constraint relation. Now what we can do here, mg for the block of mass m, mg minus t is ma, and t minus f will be 2m into a. Mg minus t is ma, and this will be 2m into a. Now if I can write it here, I will get it, t will cancel. Mg minus f, what is f? F will be, f is equal to mu into n. F is equal to mu into n. So f is mu into 2 mg. F will be mu into 2 mg. So mu into 2 mg is equal to 3 ma. So a will be, I can write a will be, I will take 3 m and m will cancel out. This m will cancel out, and 3 will come down, and this g I can take common, 1 minus 2 mu. 1 minus 2 mu by 3. So I can say my option C is correct. Okay, let's see the fourth question. A stone is dropped from a height h. It hits the ground with certain momentum p. Now the same stone is dropped from a height 100% more than the previous height. Momentum when it hit the ground will change by option A 68%, option B 41%, option C 200%, option D 100%. Okay, let's solve this question. First of all, this is the ground, and I am taking a stone and I am dropping it from a height h. The mass is m. So what will be the velocity of the stone at the bottom? That will be v is equal to root over of 2gh. By simple kinematic equations we can find. So what is the momentum? Let's say p1, that is equal to p also. Momentum p1 will be equal to p, that is mass into velocity. Velocity is root 2gh. Now what is my new h2? h2 is 100% more of that of h1, that is 2 times h1, that is 100% of h plus h. that is h plus h, that is 2h. Now what is my P2? P2 will be mg root over of 2g into 2h. So I can write here it is root 2 into p. This is root 2 into p. Now if this is root 2 into p, so I can write here p2 minus p1 by p1. This is my percentage change into 100. That will be root 2 minus 1 by 1 into 100. Root 2 is 1.414. 1.414 minus 1 by 100, that will be 0.414. 0.414 into 100, that will be my 41%. So my correct answer is 41%. So that's all for this video, and in the next video we will be discussing the next problems. And if you like our content, then please subscribe to our channel and hit the bell icon. Thank you.